So I want us to see, while we want to develop the procedures with the tools, right? So you can see conceptually what's happening. You can also do it with the numbers and look at some patterns, right? 12 divided by 12 is 1. And 12 divided by 1, right, is 12. So let's keep going with this and see if we can notice any patterns. What about 12 divided by 1/2? Or again, think about how many 1/2 pieces fit into 12. Well, there's 2 halves in each hole, and now there's 12 holes. So that's how we get 24. And likewise, 12 divided by 1/3. Well, there's 3 1/3 pieces in each hole, and now there's 12 holes. So this is the same as, right, 12 times 3, 36. What's going to happen here? 12 divided by 1/4. Or here, 12 divided by 1/6, right? Do we see a pattern that's happening? Right? We just thought about, well, there's how many 1/4 pieces in each hole? 4. And now there's 12 holes. 12 times 4, 48. Right? So this can also help this develop this idea of multiplying by the reciprocal. Same idea, 12, 1/6. How many 1/6 pieces fit in a hole? 6. How many do we have? 12 of them. So 12 times 6 is now 72. And then what's going to happen here, right? 12 divided by 1/12. And we see as this divisor keeps getting smaller and smaller, right? It goes 12. Here, maybe I'll use a different color, right? 12 to 1 to 1/2 to 1/3. What's happening to our quotient? It goes 1 to 12 to 24 to 36 to 48 to 72. And, it's, I picked only unit fractions. You can think about, we could have divided by, we did 1/2, 1/3, 1/4. We then missed 1/5. 1/5, right? 12 divided by 1/5 would be the same as 12 times 5, 60. 12 divided by 1/7, 1/8, 1/9, 1/10, 1/11, 1/12 is all going to be the same, right? This is the same as 12 times 12, or 144. So you can show all of the multiples of 12 if you would like. I was just wanting you to get into this same understanding of where this idea of multiply by the reciprocal comes from, right? How many pieces are fitting in. And so if you can develop this with our unit fractions, right? 1/2, 1/3, 1/4, 1/5, 1/6, right? Keep going. Then you can, once you get that procedure down, now you don't have to worry about it, right? Now they understand where it comes from, and now you can use it as this flip and multiply, or multiply by the reciprocal. And that's really important to do, but you have to do the beginning, right? Lay that conceptual understanding first before you get into the procedures. And now I want to show algebraically, like, why does this work? And so we can do 12 divided by 1/4. What we want to see is, right, this whole 1/4 is in the denominator, but I want to get rid of it. So what would I multiply 1/4 by to have it multiply to 1? So that would be, and then whatever, right? And then I need to keep this multiplicative identity. So whatever I do to the denominator, I need to do to the numerator. And so what you see is this 12 times 4 in the numerator, and then we have 1/4 times 4 in the denominator. And so 12 times 4, right, divided by 1, these two just divide to 1 or multiply to 1, right? 1/4 of 4. And that's what leaves us with, oops, the 12 times 4, which is 48. So no matter what, and so maybe say, I don't know, we want to keep with 12. Let's do 12 divided by 2/5, right? So algebraically, we could do the same thing. If I keep 12 in the numerator, I have 2/5 in the denominator, but now I want to right? What is going to multiply by 2/5 so that my denominator is 1? Well, what multiplies 2/5 to get 1 is 5/2. And so since I multiplied the denominator by 5/2, I got to multiply the numerator by 5/2, right? Right here, this is my multiplicative identity. And so now we have 12 times 5/2. And in the denominator, right, is 2/5 times 5/2. Again, they just multiply to 1. And so I'm left with 12 times 5/2. And now we can think about this, as 12 5/2, or 12 5/2 of a time. So 2.5 times. Or you can think about this as 5/2 12 times. Or you can think about this as 12 times 5, right? Divided by 2. So all of those meanings, and when things are, this is that multiplicative reasoning to understand like where things are in the denominator, where things are in the numerator, how do they relate to each other, which multiply to 1 or divide to 1, and which don't. And so understanding all of this, both numerically and visually with the representations, as this idea of, right, we first started this out with how many, 1/4 pieces would fit into 12. You can think about the same thing here. How many 2/5 pieces fit into 12? And count them all out. That might take a while because guess what? 30 of them do. So what you want to do is develop the procedures and the rationale with the easier numbers and fractions so you can see how and why this works. And then you can apply it to any fraction, any number. And this includes, when there's variables in there, this includes, irrational numbers like pi, right? If you think about trig, pi over 2, pi over 4, how do I simplify that? All rational functions as well as rational numbers are going to behave this way because, this fractional relationship. And that's why it's so important to understand the hows and the whys, because this develops into all of that algebraic reasoning into pre-calc and calc and beyond.